Hello, everyone, and welcome to Minute MYP. Today, we will be talking about the topic motion. There are two types of motion, we have uniform motion and non uniform motion. Uniform motion is the motion of a body that travels at a constant velocity along a straight line and also covers equal distances and equal intervals of time, and the acceleration will be zero. So, basically, any body, so let's take this person here. They're going to be traveling to this house at a constant velocity of 15 meters per second. This is uniform motion because their velocity is not changing and their acceleration is zero throughout this motion. Now, if we look at non-uniform motion, the same person decides to walk this much distance at 15 meters per second. And then they say, okay, I'll walk for 10 meters per second at this much distance. And then they get to the house. We can clearly see that there's a negative acceleration here, which means the speed has decreased. So the acceleration is non-zero. And the body has not covered equal distances at equal periods of time. So this means that it'll cover a certain distance in this much time and a certain distance in this much time, which makes this motion non-uniform. Okay, now let's look at graphs of motion. Over here, we have a distance time graph. We can see that this is our reference point. So I'm just going to make a box here and we're going to assume that this is our reference point. Okay, and now there's a person. Let's look at what's happening at A. At A, we can see that the distance is increasing and the time is increasing. This means that there's a positive velocity. It is a constant velocity because the line is straight. Had it been curved like this, it would have been non-uniform. And we can assume that positive velocity means it's in the right and negative velocity means it's in the left. So now we can say this person walked to the right at a velocity of A. Now at B, the distance is not changing, but the time is increasing. So this means that the person is still. So whenever you see a horizontal line on a distance time graph, you can just assume or you can just tell that the object is still. Now let's look at C. Over here, we have a negative velocity. This means that the person is returning. It's crossed its reference point at a velocity of C, which is also constant. One thing we need to know about this graph, the gradient is the velocity. So, A, we have a positive gradient here, which means positive velocity, and we're saying that positive velocity is in the right direction. Now the gradient is zero here, so no velocity, no distance covered, object is still. Now we have a negative gradient here, which means negative velocity. So direction changed, which is the opposite direction of right, left. So the object is moving left. Again, horizontal line, which means that the object is still again. Now let's look at a velocity time graph. We know that the object is starting at the reference point 0 here. At A, it has a positive acceleration because the velocity is increasing with time. So if the velocity increases with time, it means the velocity is not constant. If it's increasing, then it's accelerating at a positive rate. Now at B, we also have a positive acceleration, but the acceleration is greater because the slope is steeper. If the slope is steeper, it means that the velocity is increasing at a greater rate, and that is a greater acceleration. At C, the object is not still, but it has a velocity, a constant velocity. At D, the slope is negative, which means that the acceleration is also negative. But what exactly is happening here? So over here, we can see that the object is decelerating because it's in the same direction. It's decelerating, but now it's changed its direction. So you can divide it into two parts. Over here, we see deceleration, and over here, it's changed its direction. Now again at C, we have constant velocity. One thing we should know that the gradient is the acceleration in a velocity time graph, and the area under the curve is the displacement. So if a question asks, this is a graph and you have to find the distance that it's covered, you just find the area under the curve by dividing it into different shapes. So we have a triangle, a rectangle, another triangle. And over here, you look at this area. So you have a triangle and another rectangle. So the area under the curve will give the displacement. And the displacement would be this area, which is positive, and this area, which is negative. So you subtract this by this. Now let's look at an acceleration time graph. An acceleration time graph, if there is no acceleration, the line is on the x-axis, which means that the velocity is constant. If there's constant acceleration, there's just a line above the x-axis, which can be seen in this graph as well. So let's look at a distance time graph. If we were to show constant acceleration, over here, there's an exponential increase in the velocity. So there's a constant increase in velocity and a non-uniform increase in distance. This indicates constant acceleration. Now over here, we have a constant increase in velocity, which is constant acceleration. And over here, we have acceleration that does not change with time, which is also constant acceleration.